Today's problem of the day was a variation on this. Say in your refrigerator it's 40 degrees. Oops, a fridge. And 340 degrees in the oven. The power goes out. The fridge temp rises 5 degrees per hour. The oven goes down, drops at 45 degrees per hour. And your job was to write equations that represent each situation, the refrigerator and the oven, and then to sketch the graphs of those. So in this, obviously, there are two different things that we don't know. We don't know the temperature, and we don't know the time. So if we express the temperature as y, for the refrigerator, the starting temperature is at 40, and then it goes down, no, it goes up 5 degrees per hour. So we would call this 40 plus 5 degrees for every hour. And note, that is the same thing as 40 equals 5 degrees per hour. Y equals 5 degrees per hour plus 40. This would be considered the starting point, or where the point on the y-axis at 0, and 5 per hour is the rate of change. The rate of change also tells us how steep the line of the graph is. Using those same variables, I could say that the oven starts at 340 degrees, and then it goes down 45 degrees per hour, which if I switch the order, it would be negative 45x plus 340. Again, 340 is the starting point, which in algebra we call the y-intercept, and negative 45 is the rate of change. So let's just sketch those graphs on the same set of axes. And again, I'm just sketching. So we have y representing the temperature, and it is the dependent variable, so it will be the vertical. And this is representing the time. And if we do approximately 50-degree intervals, we'll put this at 50, 100, 150, 200, 250, 300, 350 right at the top, or 340. And then the time is 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. Again, I'm sketching. So the oven starts right near the top, and it's going down only about 10 degrees. It's going down 45 degrees for every hour. So that's approximately our little interval. So it's going to look something like this if we just sketch it. So and notice that our line is going down because the temperature is getting colder as we go. So I'm going to erase this for a reason that I will explain later. Okay, so then our refrigerator is starting just below one interval, and it's only going up 5 degrees per hour, so it's going up very little, almost not at all. So if I'm sketching it, it's looking something like this. So notice it's not a very steep line. It's probably actually too steep. And at this point, somewhere it would hit room temperature, and it's not going to change anymore. But the thing I want you to understand about slope and rate of change in this problem, in a real world context, that it's starting at 340 degrees. So if I say y is equal to negative 45x plus 340, I'm going to be crossing the y-intercept up here, the y-axis up here, and I'm going down over time. And the thing that I need you to understand is that that's rate of change. And when the rate of change, when the line looks like that, it has a negative slope. And in terms of real life, that means it's going down over time or per unit. So this is a negative slope when it slants this way. On the other hand, when I have y equals, it's starting at 45 and going up 5 degrees per hour, 5x plus 45, then it's going up. Now, it's going up at a slower rate than this, so it's not anywhere near as steep. I should have made that look more, but anyway, that's a negative slope. This is a positive slope. It's going up over time. You can also see from those two things that this is really the connection to algebra. When an equation is in the form, we're going to talk about this a lot more tomorrow, some number times x plus some number, this will always be giving you the rate of change or the slope. And this will always be giving you the starting point or the y-intercept. We will be playing with these concepts quite a bit. But for today, it's just quite important for you to understand the basics of this, that this is going down and that's negative. It's going up, it's positive. And that when you solve for y, or if you isolate y, this number will always give you slope. And that's one of the reasons why exercises that you had for homework were so important. Let's just review the mechanics of solving something for y. If I say 3x plus 2y equals 9, I can't talk about the rate of change yet because it's not in the y equals form. However, I know enough about solving equations to be able to isolate this y. The first thing I want to do is get rid of the 3x so that I have 2y, and I want you to get in the habit of putting this first. And then when I divide by 2, the form that I would like you to use is negative 3 over 2x plus 9 over 2. I know 9 over 2 is not a whole number. It's 4½ so you'd have to gauge that on a graph. But this is the slope, negative 3 over 2. If we do one more, if we say 2x plus 2y equals 8. If I first subtract 2x, I get 2y equals negative 2x plus 8. When I divide by 2, I get y equals negative 1x plus 4. The rate of change is negative 1. That means it's going down 1 for every 1 it goes over. Sometimes you might want to put that as a over 1. And this plays into everything that we're talking about today, because the big idea about today is slope. In general, I hope that you remember, well, we just talked about slope in real world terms is really the same as the rate of change, how much it's going up or down per unit. And the way we think about that mathematically is that we think of it as the ratio of rise over run. Now I'm going to try my best to import a picture here. So let me remember how to do that. I believe. There we go. Wait a second. Okay, hopefully it will let me write on this. So if I want to talk about this point, yay, and this point, and this point, if I want to go talk about the rise over the run, I just find the lattice points here, and I say it's going up 1 and to the left 3. Up 1 and to the left 3. So the slope is 1 over 3, and you can see because the 3 is negative, that makes the whole slope negative. And remember, if it's sloping this way, that makes it negative. If, on the other hand, all I'm given is just a line, let's say this is my line. I shouldn't have made the points, but let's say I'm given a line without clear points. Oh dear, my thing won't work here. Okay, there it is. I'm given a line without 3 points. Oh dear. Uh-oh. Let's get back there. Okay, well, I'm going to take this opportunity then just to start here and just make a point here and there and there. And I will do my best when I put the ruler down. It didn't work so well. But let's say this is my line. Let's say you're just given a line and you're asked to find the slope. What you need to do is find these little bullseyes here. And from there, you go up 3 over 1. Up 3 over 1. You draw your stairs that give you rise over run. In this case, it's going up 3 for every 1 it goes over, so that's the slope. If I had a line that went like this, and now I am going to just eyeball it, to go from one lattice point or bullseye to another, notice it has to go right through there. I'm going up 2 over 3. Up 2 over 3. This line has a slope of 2 over 3. If I want to draw one that looks like this, I've got a lattice point here, I've got a lattice point here, I've got a lattice point here, so I'm going up 2 and to the left 3, up 2 and to the left 3, so that would make that line have a negative 2 over 3 as a slope. Okay, so then sometimes, however, you're asked to find the slope of a line without having access to a graph. Let's say I have the points -2, sorry, let me make this a little clearer, -2 and +3. And then I also have the point 4, 8. In my mind, I might be able to quickly sketch out, okay, -2, 3 is somewhere up here, and 4, 8 is somewhere up here. So I've got -2, 3, and I've got 4 and 8. And I can say, what am I doing to get from one point to the other? Well, if you think about the y-axis, or the y-coordinate, these are the ones that tell us about how far up or down. We went over 2 and up 3 to get to this point. We went over 4 and up 8. So these, the y, tells us about rise, right? It tells us up and down. And if I want to know how far it went from 3 to 8, I subtract those two things. On the other hand, the -2 and the 4 tells us about x, or how far it goes across the run. So without even having any access even to a sketch, we can say, basically, I want to know the difference between the y's and the difference between the x's. So in a really, difference means subtract. So in a very casual way, I'd say y minus y over x minus x. The actual formula looks just like this, but they make it fancy looking by calling it y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That just means if I'm looking at my initial ordered pair, this would be considered x sub 1, this would be considered y sub 1. It just means here's my first x and my first y. Here's my second x and my second y. And I can plug that into the formula and say 8 minus 3 over 4 minus negative. Make sure that if this is negative, it's not the same as the minus sign. So I add the opposite here, and I've got 5 over 6. And it's true, I'd have to go up 5 and then over 6 to get over to that point there. This works no matter what order. That's why I say it's y minus y over x minus x. If I said 3 minus 8, I would get the same answer as long as I put the negative 2 over the 4. These have to be the same ordered pair, and these have to be the same ordered pair. This would give me 5 over negative 6, negative 5 over negative 6, which is also 5/6. We get lines that don't look like that at all. We get lines that look like this. And I wish I could draw better, and I haven't solved the camera problem, but what if this is my line? Let's say I was a perfect drawer, and this point is 0, 2, if this one is 0, 2, and let's say this one is, I don't know, 4, 2. 4, 2. In each case, this point I'm at 0, and then I go up 2. Here over here I'm at 4, and I go up 2. Any point on this line, I would have to go over and then up 2. So in a horizontal line, what you'll notice is that y is always the same. And actually, the equation for that is exactly that. Y is always the same. It is always 2 in this case. So in any horizontal line, y is always the same, so the equation is always y equals a constant, some number, and you'll be able to tell from that. It depends on where it is. It's at 2 here, so that's what makes it that. Now, if I use my slope formula, I know that y minus y over x minus x will give me my slope, and this gives me 0 over negative 4 or 0. And you will also find in a horizontal line the slope is equal to 0. Those are horizontal lines. It's a little bit hard to remember this, but it's the y constant that's always the same, because you're always going up the same amount to get to that. I can also have vertical lines. So if these are my axes, and this is my vertical line here, and let's just say that this is negative 2, 0, and I'm going over negative 2 and I'm not going up at all. Well, then I'd have negative 2, 1, negative 2, 2, negative 2, 3. So let's call that negative 2, 3. And you can see that with a vertical line, it's the x-coordinate that is always the same. So in a vertical line, in this particular one, x is equal to negative 2. But in any vertical line, x is always the same, and so it equals a constant. That's what the form of the equation will always be. But let's think about slope. Slope almost doesn't make sense with the idea of a vertical line. And mathematically, if I do my slope formula, I'll say to do y minus y, 3 minus 0, because those are the two y coordinates, over negative 2 minus negative 2. I find out that I get 3 over 0, and as we all know, this is illegal in math. So vertical lines are said to have no slope. Again, to import my graph and see how I do now, because the next problems are things that you have to do. Well, no, I think you can do those. You can just count. We did enough of that. But on some of them, they'd say, please draw, through the given point, draw a line with the given slope. So if the point is negative 2, 1, and the slope is negative 3, slope equals negative 3, that means negative 3 over 1 if I want to write that as rise over 1. I first plot the point. So the point negative 2, 1 is over 2, up 1. And from this point, because this is a point on the line, I go down 3 and over 1. Down 3 and over 1. And that is the same as going up 3 and to the left 1. Either way, I have all of my points in a line, and I will try to draw my line with the help of a ruler. So this is how you would draw the line. The important thing is you start at that point. Start there and use the slope. So once we had negative 2, 1 graphed here, we then used our slope ratio, down 3 over 1, down 3 over 1. What you are asked to do is use the slope formula, but you're also asked to find the slope of each line. And let's say the line is y equals 3x minus 2. Well, you could find some solutions. Let's see, if x is 1, then y would be 3 minus 2, or 1. That's one solution to the equation because when I plug it in, it makes it true. If x is 0, y is negative 2, because 3 times 0 is 0, minus 2 is negative 2. Well, those are 2 points, that's all I really need to draw a line. So if I plot those points, 1, 1 is right here, 0, negative 2 is here. I could say, well, that's up 3 over 1. So I can see, by looking at the graph, I can see that the slope is equal to 3 over 1. However, the sooner you learn that when this is in this form, when it's y equals, this is the slope. So let's say you were asked to find 2x plus 5y is equal to 10. You could find solutions, graph them, and do it. Or you could solve for y and find 5y equals negative 2x plus 10, and then divide by 5. Well, this is the slope. And actually, and 10 divided by 5, or 2, would be the y-intercept. So the slope is negative 2/5. So you can do that as you choose. I realize these are a lot of different kind of ideas coming at you, but they all have to do with rate of change or rise over run. So good luck.